So let's imagine the situation. We have a melting pot, like they melt metals and stuff like that in factories, and the temperature is really high, and we're putting the block of zinc and it melts. So when it melts, what happens? Basically, the shape changes, like it becomes a liquid from solid state to liquid state. But then if I pour the liquid in a container, the volume will be preserved. Like if the container has the same shape of the initial block of zinc, the liquid is going to fill it up, and if I let it cool down, I'll get the original block of zinc. So what I'm preserving here by melting it is the volume, the actual amount of substance that has gone into the block of zinc. Okay, hello everyone, welcome to another episode of Millionaire Math. Today is December 31st. I hope you had a great year, and what better way to conclude the year with the last topic that we have for grade 5, the topic of basic solids, including a cube and a straight rectangular prism. Okay, so in these problems, when I say rectangular prism, I intend straight rectangular prism. That means the lateral sides are perpendicular to the base. Okay, this is what it means. This is what straight rectangular prism means, that the sides are perpendicular to the two bases. So let's begin with the first problem. What is the total surface area of a rectangular prism with dimensions 9 centimeters, 7 centimeters and 5 centimeters? As you know, the prism has three dimensions: length, width and height. So given the problem, we assume that the length of the base is 9, the width is 7 and the height of the prism is 5. Okay, think about it, 5 seconds, and let me know what you think is the answer. Okay, did you find C? C is correct. Let's calculate. So how do you draw a rectangular prism? Let's draw it together. Okay, let's make a rectangle like this, and then we'll do like a parallelogram on top of it, like this, and then use vertical straight lines straight down, let's say up to here somewhere. Okay, connect these two, and now because this edge, which is on the other side of the prism, is not visible from our point of view, we are going to use a dotted line like this. Okay, an interrupted line, and we connect here, and this is how we draw it. Okay, so as you can see, this prism has 6 faces in total. We have 2 bases, upper base and lower base, and we have 4 lateral faces. Okay, so let's name the vertices A, B, C, D, A1, B1, C1 and D1. And now the length, let's denote it with A, small letter A, the width with B, and the height, let's denote it with C. Okay, so the length is 9 centimeters, the width is 7, and the height is 5 centimeters. Okay, now in order to calculate the total surface area, we need to sum the areas of all 6 faces, but as you know, the rectangle has opposite sides of equal length. This means that three faces will have different areas and the other three will have the same area. So 2 by 2 the faces will have the same area. Okay, so this is B, this is C. So you can see that, for example, the lower base A, B, C, D and the upper base A1, B1, C1, D1 will have the exact same area because they are identical rectangles with dimensions A and B, right? Therefore, the formula for the total area would be 2 times, and then we sum the area of the three different faces. So one of the faces, which is the lower base, would have area A times B. Let's say this face on the right side will have area B times C because those are its dimensions, B and C. So B times C. And then the one which is in front of us, that's the face AB, B1, A1, will have area A times C. This rectangle in front of us has dimensions A and C, right? So A times C. This is how we find the total area. And now we just plug in the numbers and calculate. So 2 times 9 times 7 plus 7 times 5 plus 9 times 5. We calculate this is 63 plus 35 plus 45. Okay, 35 plus 45 is 80 plus 63, 143. So 2 times 143, this is 286 centimeters squared, and that's the answer. All right, let's move to the next one. Oh, this is very simple. What is the volume of a cube with edge 4 centimeters? 5 seconds and give me the answer. Okay, did you find B? The volume is simply the space which the solid contains, okay? And as you know, for cube, for a straight rectangular prism, in order to cover the space which is inside the figure, we just need to raise the base to the given height, okay? So the area of the base of the cube is obviously a squared, the edge times itself because it's a square, and we want to raise it to the height of the cube, which is again a, because the cube has all equal sides, so it would be a cubed, right? The side to the power of 3. So 4 times 4 times 4 is 64, and that's the answer. Okay. A rectangular prism has volume 1440 cubic centimeters and base area of 360 square centimeters. What is the height of the prism? Again, very simple. Think about it, 5 seconds, and give me the answer. Okay. Did you find A? 4? 4 is correct. Again, we have the same idea. The volume is the base area times the height. So 360 times the height will equal 1440, which means the height will be simply the quotient of these two numbers. 1440 divided by 360, which is 4 centimeters. Okay. A rectangular prism has dimensions 2.5, 6.3 and 4.7. What is the sum of the lengths of all the edges of the prism? 5 seconds. Did you find D? 54? 54 is correct. Let's look again at the sketch very quickly. You can see that the edges are 12 in total. We have 4 edges for the lower base, 4 edges for the upper base, and then 4 lateral edges. And you know, we have only 3 different dimensions, A, B, and C, so this means that 4 edges will have length A. This one is also A. 4 of them will have B as a length, and 4 of them will have C as a length. So in order to find the sum of all the edges, we just need to write sum equals 4 times A plus B plus C. Okay, this is the sum of all the edges, and if you calculate it, we'll have 4 times 2.5 plus 6.3 plus 4.7, which will give us 4 times, what is it, 11 plus 2.5, 13.5, and this will give us 54 centimeters. Okay, and that's the answer. Let's go to the next one. A container shaped as a rectangular prism has dimensions 30 by 20 by 40. How many liters of water is the capacity of the container? 5 seconds. Think about it. Did you find B? Well, what is a liter? A liter is equivalent to 1 cubic decimeter of volume. Okay, so in order to find how many liters, we simply convert those dimensions from centimeter to decimeter by dividing them by 10. So 30 centimeters would be 3 decimeters. Here we'll have 2 decimeters, here we'll have 4 decimeters, right? The volume will be then 3 times 2 times 4, which is 24 decimeters cubed, which is equivalent to 24 liters, because 1 liter is equivalent to 1 decimeter cubed, right? Let's go to the next one. The perimeter of the base of a rectangular prism is 20 centimeters. If one of the base edges is 6 and the lateral edge is 1 decimeter, what is the total surface area of the solid in square centimeters? 5 seconds. Pause the video if you need to and give me the answer. Okay, did you find A? 248? Alright, let's calculate it. So we have the exact same sketch as before. Let me sketch it real quick. So it says that the perimeter of the base is 20. Okay, the base we know that has dimensions A and B, length and width. So the perimeter of base is simply 2 times a plus b, right? We have a rectangle with sides a and b, so 2 times a plus 2 times b is the perimeter, right? And this equals 20. On the other hand, one of the base edges is 6, so let's say a6, right? So what do we have here? We have a simple equation for b in this case. 20 equals 2 times 6 plus b. Divide by 2 on both sides. 10 equals 6 plus b. b equals 4 centimeters. And this is how we find the width of this prism. The height is 1 decimeter, which is the same as 10 centimeters. And then we use the formula for total surface area. So A total is 2 times A times B plus A times C plus B times C. So it will be 6 times 4 plus 6 times 10 plus 4 times 10. Okay, this is 24 plus 60 plus 40. 2 times 124, 248 centimeters squared, and this is the answer. All right, let's move to the next one. Two identical rectangular prisms, each with dimensions 3 by 4 by 5, are glued together to form a single rectangular prism with the largest possible total area. What is the total area in square centimeters? Wow. Okay, think about it, pause the video and let me know the answer. Okay, well, this problem is more involving, so let's just calculate. So we have two identical prisms 3 by 4 by 5 that are glued together to form a single prism with the largest possible total area. So okay, how do we glue them together? We have to choose which face is going to be glued to which other face, right? We need the largest possible total area. The largest possible total area. So let's try to figure out some cases. Okay. Three by 4 by 5. Now let's assume that we are gluing the 3 by 4 side of the one prism to the other 3 by 4. Now obviously these two sides have to be the same, right? I cannot glue the face which is 3 by 4 to a face which is 3 by 5 because they will not overlap, alright, and the resulting figure will not be a whole prism. So I'm gluing identical faces and I have three options. Am I going to glue the 3 by 4 face to the other 3 by 4 face? Am I going to glue the 3 by 5 face, or am I going to glue the 4 by 5 face? Alright, so let's think about those three options, right? So let's choose to glue first the 3 by 4 face to the other 3 by 4 face. So I'm going to continue here, okay, like this. So again I have 5 here, 3 here and 4 here. Now this is my resulting solid, okay, this is my resulting figure. What is its total surface area in this case? So basically one of the faces has now length 10, has dimensions 4 by 10, and the other one has dimensions 3 by 10, right? So the total surface area will be 2 times 3 by 10 plus 4 by 10 plus 3 times 4. So in this case I'll have 30 plus 40 plus 12, which is 2 times 82, which equals to 164 centimeters squared, right? This is the first case, but what if I choose to do something else? What if I choose to glue the 3 by 5 face to the other 3 by 5 face? Let's consider this case real quick, okay? I'll write 2 here. Now let's assume that I've rotated the prism, so I have a 3 by 5 case here, the 3 by 5 face here, and the other side is 4, the other edge. And now again I'm gluing this together. Something like this, okay? Something like this. And now this is 4, this is 3, this is 5, this is 4, this is 4. So the total area is going to be 2 times 3 by 8 now, because the height is now 8. 3 times 8 plus 5 times 8 plus 3 times 5. So in this case I have 2 times 24 plus 40 plus 15, 2 times 68, 78, 83. Wow, am I getting the same answer? 166. No, I got 64. Now I got a bigger number. 166 now, right? Did I make calculation mistake? 20. It's 24. 3 times 8 is 24. It's not 28. 3 times 8, 24. Plus 40 plus 15. So 64, 74, 79 now. Okay. Sorry for that. I'm calculating without calculators, and you should too. 79. So what is 2 times 79? 2 times 80 is 160 minus 2, 158, right? (158 centimeters squared), and this is less than the previous case, 164. Now we got a smaller number, 158. So now this case is so far the largest possible total area. Now let's consider now the third case, okay? Again, make the same sketch. So what is the third case? The first one was the 3, 4, 5, now 3, 5, 4, and now 4, 5, 3. 4, 5, 3. This is our third case. Four, 5, 3, 3, 3. So area is going to be 2 times. Now the height is 6, so 4 times 6 plus 5 times 6 plus 5 times 4. 2 times 24 again 22. Why 20? Why 28 today is following me? This number wants to tell me something. 2 times 24 plus 30 plus 20. 2 times 50, 74, 148. Now we got an even smaller number, right? 148 centimeters squared. Okay, so we are going to say that this first case gives us the largest total area, 164. Let's see, do we have an answer like that? Oh yeah, we have C. Okay, yeah, it's not A, it's not B, C, and we cannot get to D, so C should be the largest. Yes, it is correct. Let's go. Let's move on. A reservoir contains 48 liters of water. If the reservoir is turned on each of its sides, the height of the water will be 30, 40 and 60 centimeters respectively. What is the total area of the reservoir? Okay, think about it. 5 seconds. Volume is 48 liters, so V 48 liters, which, as you know, is 48 decimeters cubed, which is 48 with 3 zeros centimeters cubed. When we switch from decimeter cube to centimeter cube, we multiply by 1,000. So if the reservoir is turned on each of its sides, its height will be 30, 40 and 60. So this means that we are given the height and we can find the respective base area when it's turned to the specific side. So if I make a sketch real quick of the reservoir, it's the same sketch as before. So this is, let's call it H1, the height in the first case, and this is A1, the area of the base. Now if I flip it around and turn it on the, let's say, right face, this is going to be A2 and this is going to be H2. If I rotate it like that, it's the same sketch. So in this case, this is H2 and this is A2. It's just rotated, okay? And then this is going to be here A1 and this is going to be H1. So, and in the third situation, if I rotate it to the face that is in front of me, flip it like that, this here will be A3 and this will be H3, okay? So basically the idea is if we divide the volume by the respective heights, we get the area of the respective faces, okay, of the three faces which constitute the parallelepiped, the three faces with different areas. So let's just do that, okay? For A1 is going to be equal to V over H1, right? The volume is the base times the height, so the base will be volume divided by height. And what were the numbers? 48,000 divided by 30. 1 0 with 1 0, 48 divided by 3, 1600 centimeters squared, right? A2 V over H2, 48,000 over 40 1200 centimeters squared. A3 will be V over H3, 48,000 over 60, and 48 divided by 6 is 800 centimeters squared. So the total area in centimeters squared will be 2 times A1 plus A2 plus A3, which is simply 2 times 1600 plus 1200 plus 800. So 2 times 28 plus 8, 36, which is 7200 centimeters squared. And now we need the answer in decimeters squared. We just divide by 100, 72 decimeters squared. If we convert to centimeters squared, from centimeters squared to decimeters squared, we divide by 100, okay? And this should be our answer. So we should get B, right? Yes, that is correct. Let's go. Question 9. A block of zinc 6 by 5 by 12 and a cubic copper piece 6 centimeters edge are melted to form an alloy in a rectangular prism 4 by 18 by what? Find the third dimension in centimeters. Wow. Alright. These problems are fun, don't you think? I find them very amusing, actually. Think about it. 5 seconds. So let's imagine the situation. We have a melting pot, like they melt metals and stuff like that in factories, and the temperature is really high, and we're putting the block of zinc and it melts. So when it melts, what happens? Basically, the shape changes, like it becomes a liquid from solid state to liquid state. But then if I pour the liquid in a container, the volume will be preserved. Like if the container has the same shape of the initial block of zinc, the liquid is going to fill it up, and if I let it cool down, I'll get the original block of zinc. So what I'm preserving here by melting it is the volume, the actual amount of substance that has gone into the block of zinc, okay? So if I find the volume, right, I add the volume of the cubic copper piece, so I get the liquid, which has volume equal to the sum of the volumes of the two metals. I shape this liquid in the form of a rectangular prism. Then I know the volume of that prism, because the volume of the prism will be equal to the volume of the liquid, which will be equal to the sum of the volumes of the zinc and the copper pieces, okay? And if I know the volume of the rectangular prism of the alloy, I can find the third dimension. So that is our working plan for this problem. Let's find volume of zinc is going to be A times B times C, the product of the three dimensions. So 6 times 5 times 12, this is 30 times 12, which is 360 centimeters cubed. Then the volume of the copper will be 6 to the power of 3, 216 centimeters cubed. Then the volume of the alloy will be volume of zinc plus the volume of the copper, 360 plus 216, this is 576 centimeters cubed. And then this will equal again to the product of the three dimensions of the rectangular prism. So 4 times 18 times, let's say, x, all right? So VA equals 4 times 18 times x equals to 576. So x will be 576 over 4 times 18. And you know from my previous videos, we just reduce, okay? 76 is divisible by 4, so we reduce here this fraction by 4. Let's see, what is 576 divided by 4? 5 divided by 4 is 1. We get a remainder of 1. 17 divided by 4 is 4 with a remainder of 1, and again 4. 144 over 18. Let's reduce again by let's reduce by 2. 72, and this is 9. 72 divided by 9 is 8. Okay, so we get that x, which is the third dimension, is 8 centimeters. Let's check if we have such an answer. Yeah, A. Okay, good, 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 good. What is the weight of the of a block of marble? 1.2 times 0.4 by 0.7 meters in kilograms if the density of marble is 2.8 grams per cubic centimeter. Yes. Oh boy, oh boy. Okay, think about it. Okay, let's solve it. We have the 3 dimensions, which means we can find the volume, and then we have the density. And now, for those of you who are new to this, the density usually is denoted with the Greek letter, this one, Greek letter, rho. Okay, this is how you say it. This is the name of the letter is rho. So this is density, and now the density is simply the ratio or the quotient between the mass or the weight, mass or weight, let me put it this way, over V, the volume. So for instance, if you know a little bit of astronomy, you know that the sun, for example, has 4 times less density than Earth. Why is that? Well, because its mass is about 250,000 times larger, but the volume is about 1,000,000 times larger. So if we have the ratio mass over volume, we'll get to 1/4, which means that the density of the sun is only 1/4 of the density of Earth. Okay, which means it's 4 times less dense than Earth. Density basically means how much substance you can fit in a given unit of volume. So if I have, a balloon, the balloon has very little density, because for a big volume I have little substance. It's mostly air. It's empty, right? Except for the balloon itself. But if I have a bowling ball, it may have the same volume as the balloon, but it's much, much heavier. There is a lot packed into a lot of substance packed into the ball, which makes it heavy. So in this case, we say that the bowling ball has much bigger density than the balloon, because for the same volume, one has little substance going in it, and the other has a lot of substance going in it. Okay. This concept is used in various, fields and in various contexts. We can talk about, food density, etc., etc. But This is math. So let's use the density to solve this specific problem here. Alright, so first we find the volume. The volume equals A times B times C, the product of the three dimensions. So we get to 1.2 times 0.4 times 0.7. This is going to be now in cubic meters. In cubic meters. So the density, however, is given 2.8 grams per cubic centimeter. So let's just convert this into cubic centimeters. So this is in cubic meters. In order to convert it into cubic centimeters, what do we do? So from meter to centimeter we multiply by 100, because 1 meter has 100 centimeters. But if we are going from cubic to cubic, we multiply it by 100 cubed, right? And 100 cubed means 1 million. So we have to actually multiply this by 1 million to get to centimeters cubed. Okay, so let's just calculate it. V equals to 1.2 times 0.4 times 0.7 is simply 0.28 times 1 million. Let me calculate it here on the side. 1.2 times 0.28. 8 times 2 is 16. 6 times 1 is 8 times 1 is 8 plus 1 is 9. 4, 2, and there is a 0 in front, which doesn't matter. So 6, 9 plus 4, 13, 3, 1, 3 digits after the decimal comma. So 0.336. Okay, so 0.336 times 1, 2, 3, 4, 5, 6. So I switch the decimal comma by 6 positions to the right because I'm multiplying. So I get 336,000 centimeters cubed. Okay, centimeters cubed. This is my volume here. And then from my formula, density equals mass times volume. In order to find the mass, I switch the volume to the other side with multiplication. So the mass or the weight will be density times volume. So it's going to be 2.8 times 336,000. Okay, I need to multiply it on the side. So 336 times 2.8, and I just add 3 zeros at the end to the answer. 8 times 6, 48, 8, 4. 3 times 6, 24 plus 4, 28, 8 plus 2, 24 plus 2, 26, 12, 2, 1, 7, 6, all right, 8, 0, 1, 13 plus 1, 14, 4, 1, 2 plus 6, 8 plus 1, 9, 1 digit after the decimal comma. So I add 3 zeros at the end, so this will be 940, 8 and 2 zeros. Okay, if I multiply by 1000, switch by 3 positions. So this is going to be in grams. 940,800 grams. The question is how many kilos. So to convert to kilos, I just divide by 1000. Again, I switch back the comma 3 positions to the left, so I get what I got here, 940.8 kilos. Okay, Okay, and this should be my answer. Let's see if I have an answer like that. Yeah, C. Okay. Let me know if you have any questions so far. A volleyball court 18 by 9 is leveled with a 4 cm screed. Find its volume in cubic meters. Okay. Find the volume of the screed in cubic meters. Well, we just multiply. That's it. Okay, just multiply. 5 seconds. Okay, let's multiply it together. So the volume is simply 18 times 9 times, and now this is 4 centimeters, converted into meters, 0.04. Okay, so we multiply. Let's do it like this. 18 times 9 is 162, right? 162 times 0.04. 8 4 2 6 with how many digits? 2 digits. 6.48 meters cubed. That's it. A. Yes. Two rectangular prisms of the same material are made. If one weighs 1.4, what is the weight of the other, whose dimensions are 3 times larger? Okay, think about it. Okay. Did you find C? This problem is relatively easy, because if we use the previous formula, let's say M1, this is the mass or the weight of the first prism, will be rho times V1, right? And now for V2, because each of the dimensions are 3 times larger, so if V1 is A times B times C, then V2 will be 3 times A times 3 times B times 3 times C, which will give us 27 ABC, which will give us 27 V1. Okay, so this means that because each dimension is 3 times larger, then the product of the 3 dimensions, i.e. the volume, will be 27 times larger than the other volume. So for M2, we have rho times V2, which is rho times 27 V1, which is simply rho times V1 is the M1, the mass of the first prism, so 27 M1, right? So because the volume is 27 times larger, this means, and they're made of course of the same material, so the density is the same, that the mass will be 27 times larger than the mass of the first, and we just multiply. So M2 is 27 times 1.4, and this will give us 37.8 kilograms. Okay, should we check it? Let's check it. Okay, let's be consistent. Maybe I made a mistake, who knows? I don't want to have it turn out that it's not correct. So 4 times 7 is 8, and 2, right? 28, 8 and 2. 8 plus 2, 10, 27, 8, 7, 3, with 1 comma after the decimal point. Yes, it is correct. 20 wooden planks 20 by 3 by 4 meters are priced at $250 per cubic meter. What is the cost of all 20 planks? 5 seconds. Okay, did you find B? 120. Again, it's a matter of calculation, so let's figure out the volume of those 20 wooden planks, okay, which will be the volume of one wooden plank, and we multiply it by 20. So the volume, convert everything into meters because the price is $250 per cubic meter, so the volume of one plank will be 0.2 meters, 20 centimeters, times 0.03 times 4. This will give us 0.8 times 0.03. So 8 times 3 is 24 with 3 digits. So 0.024, 3 digits after the decimal comma. Cubic meters. So 20 planks, 20 V is 20 times 0.024. First multiply by 10 and then multiply by 2. 2 times 0.24, 0.48 meters cubed, right? And now we simply multiply by the price per cubic meter. So price equals price per unit times the amount. So $250 times 0.48 cubic meters. Multiply first by 10 and then by 25. 25 times 4.8. Now I'll use a trick here. 25 is actually 100 divided by 4. So let me calculate in this way. 100 over 4, this is the same as 25, times 4.8. 4.8 times 100, switch the comma 2 places to the right, so 480 divided by 4, which is $120. Okay, here you cannot see the 4. Yes. Okay, and that's the answer, 120. Last question. A rectangular residence 26 by 12 meters has 18.72 meters cube of concrete used for roof insulation. Find the insulation thickness in centimeters. Again, this should be a comma here. Anyway. Okay. Think about it. 5 seconds. Again, it's a very similar problem like the previous one. We just have to, well, in this case we just need to divide, because we are given the volume, the 2 dimensions. To find the third, we just divide. Okay, did you get to 6? 6 is correct. 6 centimeters. So very briefly, because it's almost an hour now, V equals A times B times C. So C equals to V over A times B. So the third dimension C, the thickness or the height, will be volume divided by the product of the other 2 dimensions. So 18.72 divided by 26 times 12. 26 times 12. And now we are going to get the answer in meters, right? So in order to convert it into centimeters, we just multiply by 100. Okay, so this is going to be 1872 over 26 times 12 in centimeters now. So let's start dividing. let's start dividing. So 12 and 72, let's divide them by 4. 1872, let's divide them by 4. So 18 divided by 4 is 4, remainder 2. 27 by 4, 6, remainder 3. 32 divided by 4 is 8. 26 times 3. Okay. Now we should be able to divide this by 13. So 46 divided by 13 is 3. 39. Remainder 7. 78 divided by 13 is 6, right? Yes, and here we get 2. So 36 and 2 times 3 is 6. 36 over 6, 6 centimeters. And that's the answer. Okay. All right, this is the last show for 2024. Next time we are going to make a recap of the various types of problems that we've considered on this show so far. Fractions, decimals, basic geometry, basic solids, okay, everything we've talked about. And then afterwards we're going to continue with solids. We have to still discuss what is a pyramid. We have to solve problems with pyramids, with other types of solids, a cylinder, a cone, a sphere, etc, etc. Okay, so we're going to be doing solids for some time, and then we move to other stuff. Thank you guys so much for watching this video. Have a happy new year. Have a great celebration, and I'm going to see you in the next one. Bye for now.